Okay.
We're live.
Nice. We're live. We're Geology 111. We're here to talk about plate tectonics, and we're trying to think of different ideas that we could use to test plate tectonics. I'm Andrew.
I'm Jordan.
I'm Brianna.
Hey, Brianna. So, have you thought about at all like the prompt or anything, or?
No.
So I'm kind of curious. Like he talks about like how would we test plate tectonics if we had an unlimited budget and time or something, or resources. So I don't know. Like I guess we have to find out like what do we want to test or.
Right. So the main cause is the heat, right?
Yeah, I think so. Like the convection.
And then is there anything else that causes it, or is it just the turning it?
Well, like, isn't there two theories? Like, one theory is that the lithosphere goes down and then melts deep, close to the core, and then that rising goes back up. And then isn't there another one where it's like a cake almost, where it's like different layered? Lithosphere goes kind of a little bit, but not really. And then it just cycles in that smaller layer back up. Do you guys remember reading about those?
I remember that first one where it's like the way like it kind of recycles itself. So it's like
in both it recycles it. Just depends on how deep it goes.
Yeah.
And then like in the layered one, it talks about.
So the first one it goes all the way down to the outer core.
Yeah, I think
it goes
so.
Through the mantle and everything.
Yeah.
And then the second one it just touches the mantle and goes back up.
Yeah, I think it only goes down to, or stays in the asthenosphere, I think is what it is. It's lithosphere, asthenosphere. So I think it just stays in the asthenosphere, and then it doesn't even go into like even the upper mantle. I think that's. Do you remember anything about that, Brianna?
So sorry.
That's okay. Anyways, those are the two ideas.
If we were to test it, we would just take a huge drill, drill a mile down.
That's what I'm thinking.
Drill to the core. So okay, yeah. If you do that, if you do the drill, would you take out a core sample, or would you like build an elevator? Because this is like unlimited money, right? So in theory, you could build an elevator that could resist the heat, and you just drill all the way down.
Well, how hot are we actually talking? Is it magma down there?
No, well, I think like the
molten core.
Yeah.
Well, so we're going down to the core then. We can't even get in the core, right?
Well, like unlimited money. You can do anything with unlimited money, right?
I think it'd be really cool to like kind of drill down to the center. Cause like, how do we even know exactly like what's in there?
Yeah,
because we've never actually seen it. So it's like go down there and see if our theories are true, and like create some kind of like container we can hold like a piece of this core. That's what it really is.
Yeah. What do you hold something molten in?
Yeah, that doesn't melt.
Iron Man suit.
Iron Man suit. There it is. Anyway, so if we were able to drill down and actually see everything, that's one way we could test our theory as to whether or not it goes all the way down or if it stays in a certain level.
But what would we even see then?
That's a good question.
Even if we had an elevator, it's not like plate tectonics is happening super fast.
That's true, because it takes like years and years. So you'd almost have to just
be like a time capsule.
Yeah, a time capsule, or just record it.
But if we knew the heat at different levels, then would we know?
That's true. Yeah. Or so that'd be an option. Or if you could somehow create a sensor, it'd take forever. But if you could get a sensor, you put it in the lithosphere that's going down.
Yeah, that's actually what I was thinking. Yeah.
Like GPS.
And then it follows, and then like after a million years, yes.
Yeah. A million years later. They didn't. I think he said unlimited time too, so we're good on that, right?
So we don't have to worry about July.
So by the time we're gods, right?
Exactly.
Yeah. Just speed it up on our own.
What are some ideas you have, Brianna, of how to test plate tectonics?
Well, I was thinking a sensor too, and we could place them on the borders of the three largest and see what direction it might go, if it's different or if it's the same.
Wait, sorry. So you said place a sensor on the
On
what?
the-
Can you see where it goes?
Plate edges of the plates
Oh, on the plate.
and see if they vary in speed or depth or anything.
Yeah.
That's
Yes.
probably the easiest way, isn't it? We're talking about drilling, and you're talking about just put it on the edge and see where it goes.
Like we did, but
Yeah. I think something that's always was really interesting during our first lab is we were looking at Google Earth and they talked about Mariana's Trench and how deep it is. I think it'd be really cool to go down there and see, like, I was curious, since they talk about the trenches are where it's like it's formed because it's like converging and one's going under the other plate.
Subduction.
Yeah, subduction. To see, I want to know like what the temperature is down there. And like, I don't think we've yet made a submarine that can descend all the way to the bottom of the ocean floor just because like the pressure. But I think it'd be really awesome to go down there and just see like kind of what the temperature's like what kind of activity is going on down there, like in the very deepest parts of the ocean.
Isn't it like the average of just like 2 miles down?
Yeah, it might be like an average, yeah. I know like they're saying
I mean, they found deeper ones. What was it, like 40,000? Was like the deepest one. It was like way deeper than Everest.
yeah, it was like 5 miles or more. But that's kind of something that's interested me in the things we've done so far.
Yeah. So if we were to put a sensor in, we'd want to do in the areas that move fastest, right? Is
Yeah.
that the ocean ridge? Is that where it goes fastest?
The ridge, it might be.
I don't know if it goes.
Like, what if we put it down a volcano?
Well, I guess it does because you have
After
the
it's
youngest. You have
It's
the
like-
youngest
it's like
sea
coming
floor,
up.
right? I was
Yeah.
thinking in terms of fastest because like that's where it's created. But I don't know if there's do you know, Brianna, if there's like a certain spot that's quicker? Do you remember anything from readings?
no, I will look at it.
So wherever there's more earthquakes, right? That's what happens more often. Would that be a fair statement?
Like along the boundaries, like the plate boundaries. I think so. But
Well-
yeah.
The Nazca plate fastest.
Is that what it says?
Yep.
Wow.
First answer on Google.
Good job.
Nazca's the one like right off the west coast of Africa, right?
Nazca, that's like, I think that's right near Mexico. I'm gonna look and see.
So west coast of Central.
So that would be one way is to put a sensor on the plate and see how quick it moves at the edge. Well, haven't they done that though?
Probably,
Yeah.
But it's still gonna want it.
Because didn't they have like in the book? Didn't they have like Didn't they do like radioactive testing on certain spots?
Mm-hmm. To see how old it was.
Yeah, see how old it was, and then like depending on how old it was, told you how far away it was from wherever it was created, right? So the younger it was,
Right.
the closer it was. Like, Brianna, did you do that lab with like the age of the ocean floors
I don't know. I'm so
on the
sorry.
Google Earth?
I'm taking 5 online classes and they're blurred.
And they're blurred. I believe you. Anyways, for us, they had us do this Google Earth like texture, and it showed like from the ocean ridge that the farther you went out from the ridge, the older it would get.
Oh, right, that first lab.
Yeah, and
Mhm.
it was like right along the coast of the U.S., like the East Coast was like the oldest.
Yeah,
It was,
and
like,
it was
furthest
only
from-
up to like 180 million, right? Years old.
which is relatively young. It seems like.
Yeah, and so like they had talked about
I
like
guess if you compare to the 4.8 billion.
yeah, 4.8 is the oldest plate terrain.
Or that's when the Earth was full, right?
Oh, that too.
Yeah, the
Or
theory.
no, there were two. 4.6, and then what was the other one? Like 8.1.
I can't remember.
There were two like birth dates of the Earth, right? One
Supposedly.
was created, and then maybe first life was found 4.6 billion. But I think the rocks are found like 8 months.
I know there's an area around. I think it was like the Marianas Trench area that was like the oldest on the Earth. It was like a billion years old or something. But
Yeah, so that's one other way we can do it, is do a sensor and have it move. Or they do the radioactivity and figure out how old it is. And then we did it in the lab. We figured out how fast it was moving, didn't we?
because we took
The
it
what was
was
it? We did
The distance and travel by the millions of years.
yes, we did
Exactly,
how distance from the trench and how old it was, and that would give us the rate at which it was moving. So that's easier with ridges, but it's not necessarily easier
with like the
anything else.
subducting areas.
Yeah, subduction.
So I have a question. Are you guys taking the lab component as well?
Yeah.
Yeah, I'm not. So,
Oh, sorry.
Oh yeah. 'cause you didn't-
oh, did I miss something?
No, sorry. That's just something that we did
No, I'm
because we're
really
signed up for it. You aren't, so no worries. No worries. Yeah,
Yeah.
I didn't even think that.
I'm relieved I'm not behind.
No worries. No worries. So what would be?
But with heat though, like if you found out the temperature of a rock, and then you took the temperature of like that same, or you even just drill a sensor down 2 miles and take the temperature of it down there, and then a week later you found out the temperature change. You could just make a graph of that, right? If it's increasing or
And see
decreasing.
like if it's getting closer or
At
further
least you
away.
can make a quicker projection. I don't know if it'd be like a fact, but it's faster than 10 million years.
Yeah. Yeah, that's always a challenge.
With unlimited budget and time to test a theory of plate tectonics.
Yeah.
So like we are gods now. We don't run by time.
Turn it invisible in one half and look at it like a gumball.
Yeah.
Sorry, you were cutting out there. I didn't quite understand what you were saying.
I'm sorry, you guys cut out too, especially I think Ben.
Oh,
It's
sorry.
like we had unlimited time. We had to figure out how to turn the world invisible and then put a trench down to check.
Oh, okay. Yeah. Gotcha.
Yes.
That makes
So,
sense. Yeah, because then we get to see it. And that's, yeah, we had talked about that too, like just drilling down, like being able to drill and then also build a support system around it to where you'd be able to put like, observation posts out or whatever and get different temperatures.
Sorry.
No, you're fine.
Oh, we're cutting out still?
A little bit.
Yeah, that's a challenge. This would be even more fun if we were all on Google Hangouts. Then everybody'd be cutting out. Oh, that'd be so much fun.
I think it'd be interesting, like, just a thought that came to me is my topic for the GEO journal is petroleum deposits. I think it'd be interesting to see how, like, just how my mind envisions it is in the Earth's crust, there's like this pocket of petroleum. And how does that, like, if a petroleum deposit's like under Texas, like in 50,000 years, like, is that going to shift over to like California area, or like what happens to like the deposits of our minerals as time goes on? Like, are they shifting with the plates, or I don't know. I think that'd be something interesting to find out. Like in 50 years, where are kids going to be drilling for oil or something if they're going to use oil?
Yeah, if they're going to use it.
Hopefully.
Hopefully. Hopefully they'll use it. Yeah, that's an interesting idea. Because didn't they talk about like volcanic chains are caused because of plate movement?
Mm-hmm.
So like Hawaii and like Midway. I think it talked about like from Midway to Honolulu or something.
Yeah. There's like that chain that like
There was
it
this one
gets
plume.
older.
Yeah, this one plume of volcanic molten lava, whatever, was creating all these volcanoes in a chain. So that's another way to measure the time.
Yeah.
They're already doing. So I don't know how he's talking about figure out a new way. Okay.
Brainstorming.
Yeah.
But
So it makes you wonder if the molten is stationary would it depend on the depth of the minerals as to whether they would stay stationary or if they would move? Because like mountains, they're moving all the time, right?
Mm-hmm.
Well, I guess, but they move with the plates, right? So I guess in my mind, it would depend on how deep it is.
Yeah.
My uneducated, uneducated and humble opinion.
Oh man.
And they found the texture of the core through the seismic waves. What was it?
Seismic, and then I think there's like
What are those?
magnetism to find out what it's made of. Because the core is what makes the.
So the faster it comes back, that means it's a liquid, right? And then if it came back slower, it hit solid.
I think it might be vice versa.
Is it vice versa?
I can't remember. It's something like that.
So I mean, if we already know that, though, would we even need an elevator?
Like if we do, because then we could watch it.
Yeah.
And because they still debate on how deep the lithosphere that's cooling goes. Because how do you track that? Because
once it goes in there, it's gone.
And soon that temperature becomes very close to everything else, and it starts to mix together, and you're like, I don't know. So that would be the advantage of making it invisible, or doing the drilling down, is that you'd be able to see it, and you'd be able to have those. So if you're doing the drilling and everything, you'd also have a suit that allows you to live while you're down there. That'd be cool. Everything would have to be super high tolerance to heat. That'd be interesting. Like all your instruments, all of your everything.
And gravity would change.
They're all made of.
And gravity would go wonky. And magnetism would go wonky. Because you're getting closer to because wasn't there that part of the reading where it was talking about the magnetic poles and how sometimes they shift?
Mm-hmm.
Wait, would there be one point where you would float before you hit the ground? Wouldn't there?
Before you hit the core?
Right.
Could be.
What do you think, Brianna? Is there a spot close to the core of the Earth where you would be weightless?
I don't even know.
If you weren't crushed by the entire Earth, you would be weightless, right? Because you'd be pulled equally in every direction.
Yeah, that's weird. I don't know.
Would you be pulled or crushed? That's the question.
Gravity neutral.
Well, I mean, if you dug a tunnel, nothing's touching you. But I wonder if you'd just be pulled apart.
Sorry, what'd you say, Brianna?
It says the core of the Earth is gravity neutral.
Oh,
Are you Googling it?
Google is my favorite thing ever.
That's a good idea.
Space. So space is in the core of the Earth. Right? Gravity neutral? Is that what it means?
It's this paradox.
I mean, I don't know how we know this, but we've assumed it's gravity neutral.
Yeah, I think that's why it'd be so interesting to go down there and see how everything acts. Take some water down there or something and see if that before it blows away.
Have you guys seen the movie Core?
I haven't seen the movie now.
Had a action movie. It's terrifying. I was too young to see it, but it's all about drilling down to the center of the Earth.
The core.
The core.
I haven't seen that one, but I've heard about it. They take the atom bomb down to the core or whatever.
Oh,
I don't know. All I remember is it scared my whole family so bad. It had my little brother in tears. And
Oh,
so
gosh.
I was going to ditch people along the way.
Oh man.
Yeah.
I think we should watch that as research, and then we can come back together and reconvene.
Reconvene.
Just show a timer.
No, I set one up kind of late though. I mean, no. I don't know. We talk about this for an hour. So.
It's pretty good.
Yeah, so we've got about 20 minutes left to be 45. Any other random thoughts that come to mind on how we can observe or prove a theory, any theory?
I guess
What
we could Google an article. and
could we do a different theory? So like we've talked about, it's the lithosphere that causes them to move because of the heat and the convection and everything else. So what if there's another theory? Anything. We've got 20 minutes.
We could Google alternate theories of plate tectonics. I guess that's probably what she's doing right now.
Yeah.
Somehow the moon's gravitational pull is affecting the Earth.
Yeah, it could be the waves. The waves are churning it.
That was one of the homework problems. Wrong answers.
Yeah.
The moon is causing the
tidal.
plates to move. Yeah, tidal forces. Yeah. Anyways, that's funny. How can we prove that it's not that? That's a question for you. How can we prove that it's not the moon?
Destroy the moon.
Destroy the
See what
moon.
happens.
Just, send a nuke up there. Bye-bye, moon.
The moon's so small, like in comparison to the Earth. I bet, like, if we did have a nuke, we could knock it out of orbit or something like that. That'd be kind of cool.
Or you just push it further away. And then push it back when you're done with an experiment.
Yeah.
We'll be fine with that.
I think one thing that crossed my mind though when we were reading was how, like, in church we think that like a Pearl of Great Price talks about how the Earth's going to become a Urim and Thummim. It's like,
Roll.
how is that whole process going to work? Like, if it has anything to do with what we have now, what's happening now? Going to turn into a ball of glass.
There's the invisible. There's the invisible. When it turns into a ball of glass, we can see all the way through.
Millennia.
Yeah.
That's our theory. We wait until the millennium and ask God.
That's still faster than 10 million years.
That is. Hopefully, right? Fingers crossed.
Yeah.
2020.
2020.
Oh man, you can have kids fast.
I know. Oh, you can have them during millennium. Anything else? What
I'm
could
assuming
cause
that
it?
say using GPS is good.
GPS.
So, yeah. That's
Yeah,
probably
okay.
just our sensors. But I was thinking there's that only tracked movement from where it was placed. Speed, not just local position.
Track the land speed, you said?
Yeah.
Yeah. See how fast. I wonder if we could calculate that. See how fast a plate's moving.
Well,
They
don't
can't. They saw the fastest one, the one just west of South America, moves 3.7 centimeters a year.
3.7 centimeters.
3.7
And then
centimeters.
doesn't
That's
like
pretty
the
fast.
North American? Yeah. Doesn't the North American plate move like 2 centimeters? Or something like that? Anyways,
I
yeah,
don't know.
they've tracked
What's that?
the movement of plates.
That's cool. Yeah, because I was thinking, like, on one of the videos we watched on Pearson, it showed, like, the fault line. It'd be cool if you could put, like, lasers that, like, were really, like, shooting at each other and just see, like, over, like, 10 years to see how those move,
Or like just like a sensor bar.
Mm-hmm.
Or even
Yeah.
you might almost want just like a plate to account for height change and then the movement change. That'd be cool.
That'd be sweet.
So that'd be cool to track how where they move. But then the prompt for this video is why.
Yeah.
So that's
Well, so how do we know all these layers of the Earth, but we don't know how to predict earthquakes?
That's a good question. Well,
Like
I think
if we
they
got
do
it down
have
to a
some like earthquake prediction.
Right, but nobody actually knows, it seems like.
well, like how far out are you talking? Because like they can feel the tremors beforehand, can't they? Like,
Well, yeah.
well, you always see that in movies, right? They're like, oh, it's starting to wiggle, and then the
well,
earthquake.
That's already happened, but like when nobody's been able to predict like these 8.2, 8.5, you know. But if we can figure out what's going on down there, how fast things are moving, do we just, the only thing we don't know is the threshold for when it's going to slide?
Yeah, I
Is that
guess
what-
so.
is that what we don't
So
know?
maybe that would be my guess is like when the tension breaks, right?
Mm-hmm.
When that built up force between the plates and everything is actually going to slip.
Right.
Isn't it when it slips and breaks? That's when it actually causes the earthquake, right?
Mm-hmm.
That's a harsh installation. Just
Say, just drill an indestructible, well, right on the fault line, and then in theory you'd be able to almost watch when they would break, but at the same time, can you predict it? Like, would you have to do like a model?
I think you
The
can
tricky
know
thing
like
is that earthquakes are rarely on a known fault line.
they are on a known fault line.
They're rarely on a known fault line.
Rarely.
So
That's
it's on unknown. So it'd be hard to know where to even as well.
Yeah.
right, but since we have unlimited money, we can put these detectors on every single fault line. On
Everywhere.
every single city in the entire world. We can just play it out.
Yeah, so like you'd have your sensor and then you'd have a range on that sensor to whatever range it is. And so like at the edge of the range, you just build another one. So they kind of like overlap along the whole entire fault line.
Yeah.
Then you'd be able to track movement of the plate, and you'd be able to try and predict the earthquakes, in theory, right?
They said here that predictions are deemed significant if they can be shown to be successful beyond random chance. So they use statistics, and I think it relates to like when the last earthquake happened and what the consequences of that earthquake. Because like when one earthquake happens, it's like a plate shifting and it's going to cause another shift somewhere else eventually. And so they use like statistics to, I guess, somehow predict. Although it's not like perfect, of course, but
Right, there have only been like a couple scientists or a handful of scientists who have actually been correct like more than twice in their entire lives.
mm-hmm.
And they all swear that they know.
So like, trying to get back to the why plate tectonics happens. So we talked about doing a well. We talked about just making the layers of the earth invisible to see. What would happen if we were to try and build a manned vehicle
Like,
or like a drone? What happens if we do a drone
there you go.
and then you could have it like a drill submersible lava-proof thing, right? And you have it just like basically doing patrols down there to be able to try and predict. Or if you do it, or if you try and have the drone follow, I don't know, a predicted path of the lithosphere down.
So what causes the churning?
That's what we're talking about.
I mean, if churning causes plate
Heating and
tectonics,
cooling.
what causes the
Sorry, what?
Cooling, I thought created the
Yeah, heating and cooling.
how do we stop heating?
Yeah, so like that's the theory that they've said in the book. Well, I think it's both of the basis of the two theories that they have in the book.
I wonder if it could be like the magnetism because of like all the metals and stuff that cause the Earth to have a magnetic field. Like if it's like pulling substance towards it, but then it like since it's moving, it kind of like breaks the pull and just like keeps circling around and just I don't know.
Or the composition changes enough
I guess,
Yeah.
is
to
the
where it's
magma-
pulled.
Is the magma churning just as slow as the plates are moving? Or is it going a lot faster? Do we know that?
That's a good question.
Oh,
It makes you wonder. Well, like from what I understood, like the whole heating and cooling is that the plates are created on the ridges, right? And then they're constantly getting created.
yeah, and they move
And so
towards
they move
the
away from the ridge and towards the
convergence zones.
subduction, right?
Yeah.
Towards the convergence zone, towards it and getting subducted underneath into the earth. So if you have the heating yeah, I wonder how much that plays in effect compared to the creation of the new plate. Because like the plate and getting created in itself, that could be pushing it,
Mm-hmm.
or it could be getting pulled by the heat
Right.
movement, or it could be both, or it could be none of the above, which is my favorite on multiple choice questions. Oh, B, none of the above. Ugh. What do you think, Brianna? Heat. What kind of heat or why?
I don't know. Gee, do you,
What was that?
Sorry, you got to speak a
do
little bit slower.
have you? Never mind. It's Arthur. So.
Oh, Arthur? Did they
Yeah. No, they said that you do the hokey pokey.
do those?
I don't know. I think that it could be the fact that the heat is rising and then it's cooling and settling separate directions. So that it's kind of like a wave.
It's like simultaneously.
Yeah.
That's probably pretty accurate.
Yeah, so like the heat goes up in one spot, and then it starts to cool, and it goes along the top with the lithosphere, and then as it cools too much, and then it goes down. Is that what you're thinking? And then it
So it's like an
warms
extremely
up.
slow boil.
Yeah.
Yeah.
I think that they use. Let's draw circles on the screen. Didn't they use that in the book as an example of like the
the
boiling pot
the
of water?
Yeah. Mm-hmm.
So that's
So the inner core could be changing in diameter as the outer core once is being pulled in and becoming a solid,
That's a good idea.
becoming very hot. And then I guess it'll cool off. And it just kind of does that then. It's kind of.
I don't know. I guess it depends on what it's made out of. Because if the mantle or if the core is so hot that it doesn't matter what the composition of the magma outside of it is, and it just heats it up equally, then I don't know if it would change. But if it's susceptible to the different compositions of the magma, then in theory, yeah, I guess it could.
And I always thought of it as like a ball pulling in all this mass. But I guess it just like it's gradually the gravity, you know? And the pressure would change just gradually, not like super high out here and all of a sudden it's just a ball. Like the closer you get to that inner core, I guess it's anti-gravity. But it's not like a whole lot of gravity and then nothing, you know, it's gotta be gradual change.
Yeah, that would be interesting.
Core's like made of like nickel and iron or something like that.
But they didn't say the core was like, yeah, but they said the core was kind of like 4 point something in density, and the crust was like, I don't know,
Less.
it was like less than 10% of that.
Yeah.
But maybe it would change drastically as you got deeper in. Just a little density.
Yeah. And the composition of with the different minerals minerals.
But anyways, if that's what's churning it off, is this thing just like bulging? We can't stop that.
Or is it bulging in different spots
Right.
At different times, yeah.
at different times?
It's like a lava lamp.
A lava lamp. Oh yeah, that would work. Or like one of the little bubbles in the lava lamp, how it's kind of changing all the time.
But that's the other thing. If this thing's putting off heat all the time, eventually in billions of years it's going to cool off.
Maybe it just depends.
Or is it just regenerating from the sun?
I think a lot of the heat comes from friction, and so like it's gonna continue to heat, and then it's just like the recycling process. It's like the perfect recycling system. So like old crust gets recycled, heats up, and then new crust spews out, and
Yeah, super efficient conservation of energy.
yeah,
Um,
like the best science project ever.
yeah.
Do we have to draft anything for this, or is it just we have to post our video?
I think he's just posting the video when he watches it.
No way.
Brother Sherliff is the best professor.
He's gonna be amazed, blown away by our conversation.
If you're listening
I'm
to this right
excited
now,
for this.
I'd be very impressed.
Hope you're eating something.
Yeah. Oh. 5 more minutes. We can do it.
How does everyone's GeoJournal topic relate to plate tectonics? Brianna, you first.
Well, mine is, I forgot what it is. Give me just a second. It is sequence stratigraphy, which is the lines in the rocks, so the different levels,
Oh yeah.
minerals and lack of minerals and types. I don't know. I haven't dived into it enough to really. So, but I'm pretty sure that it originally came from plate tectonics. So, it had to come from somewhere, and it was in layers. So,
What about you, Ben?
So I was talking because my emphasis is petroleum engineering.
That's mine too.
Really?
Yeah.
I guess that's why we're in this class now. But he was talking to me about visiting this one website. I forgot what it's called. It's like you probably visited it. It's like the Petroleum Engineering Society or something. PES.
I haven't seen it though.
So they just a bunch of these like CEO guys post all this stuff about their businesses. But it's actually pretty interesting about like all the political stuff that's going on through it, and like where they find it, and, like, what they have to do to get to it.
Yeah.
So it has nothing to do with plate tectonics at all.
One thing that I was kind of curious about is because mine is my topic is, like I said, petroleum deposits or whatever, but I posted something about fracking and how fracking, they send the water down there and it sends really high pressure water and it opens cracks so that way they can get out like the stored oil and like shell rock and stuff. Like, does that like create more stress so that way it like causes earthquake or something like that? Because it's like really going in there and just like ripping things apart. But I don't know. I wonder if like human involvement influences frequency of earthquakes.
Right, like burning forests down. That kind of like
Yeah.
ruins plant life, you know. But also the forest needs fires to have those seeds or something.
What was your topic on?
I can't remember.
So if there were
Well,
no
like-
if there were no earthquakes, what would happen? Like if they never converged on each other.
Well, if there's no earthquakes, there wouldn't be any movement, would there?
And
Well,
It'll
no,
still
there
be
could
Pangea.
movement.
It'd still be Pangea.
No, because you can still have an egg, shake the egg, and the yolk will move around.
but the shell
But the
won't.
shell won't.
Yeah. So like everything would be exactly where it was in the first place.
It's like
on the outside.
if we could make our crust hard enough, there would be no more earthquakes, right?
In theory, yeah.
So lots of cement.
Glass.
Lots of cement.
That's what the
Well, like that's
no more earthquakes.
very glass. That's like the thing, though, is that like you have these completely, almost unpredictable forces.
Or is that what allows all the energy to come out? So would it just build up and build up and build up?
And explode.
And then get a fire blows up.
That's true. Maybe it has to be malleable to a point so that the Earth doesn't, so it can use the energy, but at the same time conserve it enough to reuse it and everything else and whatnot. That's
So I guess
interesting.
one thing we have discovered, like what Jordan said, it is the perfect science experiment. Like however it works, it's down to science.
Yeah, it's an art form. It's not just science. It's science with style.
For real. It's like every
Like there's no coincidence of what's going on. You know? Like
Oh,
even
yeah.
though it may seem like a disaster to us, if it didn't happen, it seems like something way worse would happen.
Yeah. Stop earthquakes, and the Earth might explode.
Yeah.
Yeah.
Yeah, it's. Oh, I'm so excited to be able to go and learn how to build a world. That'd be cool.
Mhm.
That's what we're doing right now.
Yeah, we're getting the basics, right? We're getting the basics of the basics that the imperfect humans have gotten the basics of.
Yeah.
Oh, we're getting the watered down version. That's funny. I can't
think
remember what
it's-
my topic is.
It's been a great discussion. We just hit 45 minutes.
A plus.
Thanks, brother.
Yeah.
Thanks, brother.
Thanks for the show.
I apologize if you listen to
We tremendously enjoy a good grade on this project. We put time and effort into this. Anyways,
Brian, you
That's
gonna
it.
say the closing prayer? Just kidding.
just kidding.
Yeah.
Alright. We've all agreed with everybody else has said. We all know little. All right.
Do we do this every week?
Yep.
All right. We're going to go ahead and end the live portion now.